In this video, we will introduce more database concepts and discuss the process for creating a schema from a design. Some important terminology for you is model, schema, data. We often confuse and overlap these terms, and they may have somewhat different definitions depending on what website you visit or what book you read or what table you sit at during lunch. But we will try to provide broad definitions for these so that we try to use them correctly in our work. Even before we get to model, schema, data, let's talk about the word relation, because it is used in two different ways and it does get confusing. A relational database means nothing more than a database where the data is stored in tables. That's all it means. If you go back to the original paper defining a relational database, and I encourage you to do that, you will find that a table is called a relation. This is a mathematical term. It has its roots in algebra and calculus, and it is commonly used throughout the database industry. A relationship is defined as some kind of connection between two tables, typically implemented through a primary key in one table and a foreign key in the other table, leaving you with a many-to-many relationship or a one-to-many relationship, or even one-to-one sometimes. These are two different terms, and it's important that when you hear the word relation or the word relationship, you stop and think what it means in that context. Once you've got those two terms figured out, keep in mind that none of this means that anything is normalized. We often say, I need a relational database. That really doesn't have a lot of meaning to most people. They just think that's data stored somewhere that can be edited and retrieved. It does not mean it's normalized. Now, this is all very broad and general, and we'll drill down and talk more about these terms as we go through the semester. And I encourage you to research these terms, and I insist that when you use these terms, you think about whether you are using them correctly. Getting back to model, schema, data, the model is the underlying physical representation of the information and actually of the schema. There are many different models. Some models are wildly popular. Some models are fad. They come and go. Relational models, SQL Server, Oracle, MySQL, for example, are wildly popular and some of the most widely used databases in the world. Other types of models could be object-oriented, a graph-based model, a NoSQL model, a document-based model, and on and on and on. In our class, we are strictly relational. We are strictly Microsoft SQL Server. If we delve into any other models, I will mention those to you and I will be clear about that. You can assume then that when you are starting a design, your model will be relational. How is the model decided? Well, that's probably something that's above your pay grade at work. It's probably decided for you because that's what they've always used, or that's what the customer told them to use, or they're branching out and they might want to try something different. The schema is a set of empty tables, corresponding constraints, and keys. There is no data associated with the schema. We can use a schema to store data. Now, we have seen before, and we will see in the future, that the word schema has different variations depending on what database engine you are using. For example, in Microsoft SQL Server and MySQL, two competing products, the word schema means a different thing in each. But generally, for research purposes and for discussion purposes, we will say it is a set of tables, constraints, and keys. Once you have a schema, you instantiate that schema and you store data in it. We can have multiple copies of the same schema, storing multiple sets of data for multiple customers. This is where the database becomes useful to the customer because it has the customer's data stored in it. A deliverable product then to a customer includes a model, a schema, and as the customer uses the product, data accumulates. Moving on to general design concepts. In this class, we are skipping a lot of the design process. I want to provide you some background, and I want to emphasize that what we do in the real world requires extensive design. Whether you are writing code, whether you're designing a mobile app, whether you're writing a database, whether you're hacking into a rogue government server, you need some design. We don't do things off the cuff. We are carefully planning what we do. But in this course, that is not always evident. There are three general design steps: conceptual, logical, and physical, when you're creating a database. In this course, we are almost completely skipping over the conceptual step, and I will be forcing you in a general direction when you're designing your schema, I guess. So keep in mind that there would be a lot going on before we even got to the point where we do work. Our general design concepts and things that we are going to cover a little bit in some cases and cover in great detail in other cases. Decide if you need a computerized database. Well, in this course, we've already decided that we need a database. Sometimes your customer will come to you, then you can tell them they can get by with a shoebox and some index cards. Sometimes they need a redundant, cloud-based, multi-user database, and sometimes they don't. Number two, figure out who knows what's going on in the real world. Who's the domain expert? This comes from the customer sphere. This is the person or persons that understands what this data should do. And then it's your job to figure out how to map those requirements into a model schema data construct. In this class, sometimes you will be the domain expert if I ask you to implement a database that has relevance to you. And sometimes I will be the domain expert because we don't have a formal customer. Number three, we are still in the conceptual design phase. Figure out what you want to store and what you want to retrieve. This is probably the most important part of any database. If you don't know what goes in it and you don't know what has to come out of it, you will not be successful. In this class, we don't have those things. We don't have a customer telling us what we need to store. We don't have a customer or user telling us what needs to be retrieved. So I will generally provide those things for you, or I will let you make them up. Either way, I will be very clear. Number four, what is our storage model? In this class, it will always be a relational database, Microsoft SQL Server. Number five, Design the schema. Okay, to get to number 5, we've come a long way. We've finished our conceptual design. We've met with the customer. We've designed reports. We've designed screens. We've had interminable negotiations with the domain expert. Now, in step 5, we are at the point where in this class we will begin to do work. So we've kind of skipped over the first 4 steps. To design the schema, we take the real world things, and those are going to become tables. Entities in the real world, the qualities and quantities of those entities in the real world will eventually become tables. When we get to step 5, I will have provided for you, for the most part, the information in steps 1 through 4. Now let's step back to the previous slide and let's stop and think for a moment. We could easily spend months and months and hundreds of hours on step 3. What do we want to store? What do we want to retrieve? What are the relationships between the entities? What are the maximum minimum values for the attributes? Can we have entity X without an associated entity Y? What color should it be? Anyway, assume that all that has been done for you, but remember that that is part of the process, and that hopefully you will learn in another class, and you will be able to apply it to get through this process from end to end. In order to be good at this, in order to get an effective, useful schema, we need to know our keys. And I refer you back to your work in the previous class, the prerequisite IT 2060. I will be using these terms throughout my presentations. Make sure that you know what they mean. Make sure you can apply them. Not just a definition, that's not sufficient for you. Make sure you can create a primary key. Make sure you can explain the purpose of a primary key. Make sure you can create a foreign key. Make sure you can explain the purpose of a foreign key. Make sure you can differentiate between all of these types of keys. These definitions overlap. For example, a primary key can also be a surrogate key. A natural key is also a candidate key. A composite key can also be a natural key. So simply knowing what they mean is not sufficient. You have to be able to differentiate between them and explain what they have in common and what they do not. In this class, we will be using SSMS. I expect that you at this point can log in, can create a table. We will become more adept at this work. We will be able to create keys, foreign keys, primary keys, natural keys. We will create constraints. We'll also create views. I understand that in IT 2060, your primary focus was writing queries, writing scripts that generated a result set by joining tables together and applying filters and functions and aggregates. I encourage you to use the designer tools in this class unless otherwise required. You cannot become adept, sufficiently adept at data definition language, DDL, SQL, to create a table in this class. If you can, great, but it was not a requirement in 2060, so I strongly encourage you, and I'm happy for you to use the designer tools. Use the table creation tool. With the table creation tool, you can build attributes, you can define constraints, you can create keys, you can define foreign keys and relationships between tables. With the view creation tool, you can do a lot of basic to intermediately complex views. Some of the queries that we created in 2060 are beyond the capability of the view designer, but for basic queries rather, the view designer is an invaluable tool, and it's much faster to use the visual tool provided by SSMS than to try to type things in by hand for most people. If you found yourself to be a wizard at writing these queries by hand, by all means go for it, but be aware that the view designer tool is there, and also fall back on it when you need to. The next thing we will do is move to the next slide presentation and model something in the real world wherein we will create a schema to provide some useful information for a customer.